give a detailed stepwise mechanism for the reaction for the formation of an activated derivative from the reaction of an amino acid with that wonderful long NN dicyclo. All right, so I'm going to start with our amino acid, and I'm going to draw it. The lone pair is going to be important on this first step. So I have my standard amino acid. I'll have this R here, and my carboxylic acid. And I'm going to draw the protection that occurs first. Now that happens on a very specific molecule. It's got a carbonyl, which is what we're going to attack. And on one side, it's a tert-butyl group. But it's a mirror of it. It's like an aldehyde. And our nitrogen is going to attack the carbonyl kicking off this side. And that's going to give us, which I'll start down here, we'll have, going to lose one of those H's when this happens. Other than that, the amino acid will be intact. And we now have, I'll do it over here, a carbonyl with an O, C, and then 3 methyl groups. But it's now protected on the N-terminus, ready to do a reaction with this NN dicyclohexylcarbodiimide. Alright, so that's my next thing that I'm going to add, and that's a pretty ugly looking structure. It has 2 of these carbon-nitrogen double bonds, and on either side of the nitrogen you have the cyclohexyl group. Alright, this gets pretty interesting how what happens now. So one of these nitrogens, lone pairs, is going to swing over here, attack that hydrogen. As a matter of fact, I'm going to change how I did this hydrogen because I want to draw attention to something. So I'm going to, instead of having OH, I'm going to OH. Have this lone pair attack that hydrogen, allowing the bond, the oxygen to keep those electrons. Alright, that gives us this protected group attached to the NH. So I'm actually saying this is just the PR, just so I'm not taking up so much room. And then I have the CH and an R and my carboxylate now because I've deprotonated it. And my dicyclohexyl has an H on it now, making this one slightly positive. The rest of that structure is exactly the same. Alright, now this negatively charged oxygen has a lone pair of electrons on it. It's actually going to attack that carbon, causing these electrons to go up towards that positive. And we end up with protected nitrogen on our amino acid. Excuse me. Where this O is now connected to that carbon with a single bond to an NH with a lone pair on it now, and then the cyclohexyl group. And the bottom looks exactly the same, giving us an activated amino acid ready for that next step on the reaction.